Welcome to the session. Greeting of the day. In today's class, we are going to talk about the various types of PLC programmings. What are the ladder programming? How we are going to do. In the previous class, we have done about the various setups of various AND functions, logic gates we have seen in the last class. Such as AND gate, AND gate, OR gate, AND or not OR gate. So such cases we have we have seen. We have seen about the AND OR logic functions, and we have seen about the latchings, and we have seen about from the latching how we can able to multiple inputs, multiple outputs also. I want to incorporate some other points of timers also here. So in this timers, you see the timers behave like a relay with coils when energized results in the closure or opening of the contacts after some preset time. The timer counts fractions of seconds. The timer counts fraction of seconds or seconds using the internal CPU clock. In the microprocessor, we have seen one clock is interconnected along with the input, along with the output, along with the all input hardware devices and programming devices. One small CPU clock is there in the internal architecture of microprocessor. So that will help here to count to timers. So different type of timers. What are they? Maybe it can be on delay. I want to on the delay of 20 seconds. After 20 seconds or after 1 hour, after 1 minute, when the pressure is given, when the input is given, the trolley should move until for 20 seconds and it can stop. It is in this 20 seconds or 20 minutes of time, the trolley will travel from 0 meter to 10 meters. And the trolley may contain the load and it can move. So I want to move the trolley for 1 hour or 20 seconds or 1 minute we can consider to shift the object from one bay to the another bay. So this is a traveling time of 20 minutes. Therefore we have on timer, off timer, when it should off. After 20 seconds it should off. So off timer, maybe on off cyclic timers, on and off to be takes place every 20 seconds. Likewise we can able to program, and the cascades and the sequential programs timings are there. So the delay on timer, the word says it should on with a delay. When an input is given to the timer coil, it means the internal relay coils is activated, therefore it counts, keep on counting. After the preset time, to our case I have told you some 20 seconds, maybe 1 minute of time, the timer contact closes, timer contact 1 to closes, and then activates the output. So how this diagrams will looks like? So I have input has been given, and then here the timer is there, such as we can put a timer TI, therefore, and then when the timer is activated here in the second run, this is I am taking this relay coil 1 as a named as timer and giving the contact, open contact here as a timer, and it activates the output 1. See, now what I am doing here, see, I am activating this input 1. Switch 1 has been connected. Switch 1 has been connected here. Here I have a switch 1. S1 has been connected. Therefore, from the switch 1, the power supply is going to the coil and it is going to count of 20 seconds. After the 20 seconds of time, this coil should give the output to the second run make contact. So this is activated after the delay. So here I have this second run has been connected to the output. So likewise, even the switch is on, after 20 seconds of time, this activates the output. Even the switch is on, it should on after 20 seconds of time. Until then it is waiting, it's a waiting time, we have to queue. For maybe the lift after operating, it should wait for a while until the persons are door closed. when we are clicking the fourth floor, after pressing, it should close the door and it should start. Immediately it should not start. The door closing time I am giving, door is operated separately. With respect to safety sensors, it is operating. So after pressing the fourth floor, it waits for 10 seconds, that is separate program. In the meanwhile of 5 seconds or 10 seconds time, the door sensors will activate and it closes in the 10 seconds. Therefore, after that, it lift going to move. So that the minimum time I am giving after 20 seconds. So like this we can able to do. This is about the AllDay timer. Now I want to off. I am going to off this. So when the input is given, S1 is clicked, the output is activated. Output also activated now. It is a running conditions. The trolley is moving. Input is given, the trolley is taken the road and it is keep on moving now. After 20 seconds it will reach from bay 1 to bay 2. After bay 2 it should stop, the trolley should stop there. Then we have to unload the component which is already kept in the trolley. So trolley should not keep on go. Trolley from starting from 0th point to the A point, to the B point, to the C point there. Some of the component we should take on the A position. Some of the component we should take on the B position likewise. So I want to off the trolley. I want to stop the trolley. I have started from the 0th point. After 20 seconds of time, the trolley, the object which is kept on the trolley could have been traveled to the position B. Then it should stop in such a way I can able to unload. So I am giving off delay timer. After 20 seconds, the machine setup should off. So the same condition we can do. And also the timer coil is activated. And therefore, after preset of time, the timer counter normally closed contact is going to open. So we will see this. You see? Now I have given a starting, trolley has been moved. I have started this and it is started to move. And it is output has been started. Output means the operation of moving motor has been started and trolley is moving now. How long it should move? At the same time of switching on, the motor should start and move. At the same time, I am going to count. This is activate. This line is moving. When the time is closed, it is going to motor and also it is coming to the timer. So I am giving the 20 seconds of time. So now it is 20 seconds is counted. Trolley is moving. After 20 seconds of time, this timer I have connected again to here. You see, I have connected again to this point. So now, this timer which is already in the closed condition, from nil, its nil position is closed, normally closed. When the timer is completed at the 20th second, the nil position is going to convert to the opposite of 1 position. Its 0 position is closed. It's going to activate. This timer is going to activate this. How it activate? This nil position to the other position. The other position is normally open. This is normally closed. When this timer is activated, it is going to activate this contact. This contact is normally closed contact. From the normally closed contact, it should activate to the normally open contact. So how I am doing now? This normally open contact is going like this. It is terminated. When it is terminated, what happens? The power source is not coming here. The power source is not coming here. And what happens? You see, this is disconnected. This is from the normally closed contact, normally closed to normally open. When timer 20 seconds completed, activated. So it is disconnected the motor. The trolley is stopped there now. Motor is rotating, trolley moving. After 20 seconds, trolley stopped there. That is called as off timer. In the off timer, motor is running. And then we have reached from one location to another location. Then it is like a bus stop from one location to another location. Travel time. We have stopped there. Right? So this is how we can able to do. In this setup, you see, in this setup I want to tell you, even when this is connected, it activates output 1, activates the timer and also activates the output 1 here. Even if the start button is a switch, let's consider this as push button. Even the start button, if it is push button is not activated, but the output 1 is latched here. See, the latching process keep on moving. The latching process is going to make the contact here. So it will keep on moving in this way. So the circuit will operate. So about this, there is an on-delay timer. On-off cyclic timer, how we are doing? So it should do on-off repeatedly. It should do. When the input is given, timer coil T1 is activated after the preset time. Yes, we know this is on-delay timer we have given. After preset time, we should give on. The timer contact closes and activates the output. Yes, up to now it is an on timer. And at the same time, it activates the coil 2. Coil 2 at the output also is activated. Coil 2 is activated. After the preset time, the timer normally closed contact is going to open from the nil position. It is going to open its contact. Therefore, it deactivates the setup. You see here. Now I am activating the normal contact 1 and it activates the timer of 5 seconds maybe, and then at the same time after 5 seconds it is going to activate here, and if it is activated it is going to activate the timer 2 here, and then when the timer 1 is activated here it also activate here, and when this activated it is going to output the 1 has going to activate. But here the timer 2 is activating here, you see. When the timer 2 is 5 seconds is done, automatically this timer 2 here it is normally closed contact. Therefore, this normally closed contact is going to become a disconnected, normally closer to normally open. Therefore, there is no supply to the T1. It is not activated. It is going to become that. Now I am connecting this output to the input 1. Again when I am pressing, it is going to start after 5 seconds. You see, after 5 seconds it is going to become disconnected. So such how we can able to make the cycles. So some sequential operations. See, an output may be activated after preset value of a previous output being activated. Sequential, one after the other. First one, second one, again first one, second one, again first one, second one, sequentially it can go. Output 2 is activated after we have seen the output 1 activated the delay between the output is done. How we are doing, you see. Now I want to activate the input 1. I have done input 1, a push button has been switched or switch is on, so therefore output 1 is connected. This output is taken as a contact here, and this output connected to a timer of 20 seconds. After the 20 seconds, I have connected this to the timer, and then it is by one after the other it is going by sequence. You see, I have not taken any second output. I have not taken any third output. Sorry, I have not taken any secondary input 2, secondary input 3. I have not given. I have a start here like a washing machine. I have a start, that's it. One input is given. What it does, first it activates the output 1. Output 1, I have given a delay time of 20 seconds. So output will keep on running. Output will keep on running. How long? Up to 20 seconds. It will keep on running up to 20 seconds. After the 20-second time, this timer is connected here. This output has been taken to here. This is timer. And after the time of 20 seconds, we are simultaneously operating this output. Output 2. In case I want to disconnect the output 1 and activate only the output 2, what I want to do here? This is multiple operation done one after the other, but by the program, here output 1 is not disconnected. Along with the output 1, output 2 will also started to run after the 20th second. This is the initial point. This is started running. This is started running here. So this is started running. Now after the 20th second, we are going to start the output. This is output 1. This is output 2. This is started to run here. But we have not disconnected. This is also running. This is also running. Now I want to disconnect this output 1. What I can do, I can able to make one more contact at this point in such a way. You see, in such a way I am creating one more contact here. That is named as nil. At nil position it is normally closed. At nil position it is normally closed. it is not activated. When it is not activated at nil position, the supply it can able to give. Normally closed contact it can give. When it is passed through, there is no such cases it can go. No restrictions. Now, when the output is activated here, this output I am taking as input to this one, and I am giving as a output 1. I am giving as a output 2. So this output is given here. When this output is activated, what happens there? This is going to nil from the nil position. Its nil position is normally closed. When it is activated, it is going to disconnect here. It is going to disconnect here. Therefore, this disconnection makes the stopping of the output 1. Such a way we can able to play the sequential operation simultaneously. This termination, resetting operations also, off operation also we can do. So some programs we are planning. The counter. Up to now we have seen the timers, the logicals, the latchings, the timers. Now we are trying to do for the countering operations. What are they? Building elements in the PLC allows the number of occurrence, how many times it is passed. A bottle we have taken on the same trolley, we have taken for 20 seconds of travel. On the 20 seconds of travel, how many products went? One bottle, one keyboard, one pen, it is went there. So I am detecting this is a one count, one object count. This one object count. Now the sensor detects count 1, count 2. Let us consider, I want to fill on the trolley, I want to fill the box, a biscuit box of a 20 objects or 20 biscuit packets in the box. One object detected, stored. Second object detected, stored. Until 20 counts, the trolley should move, and therefore the biscuit can fall in the box, filling box, and it can there. So after 20 counts, the trolley should stop. The object should not fall in the filling box. Therefore, each box may contain 20 counts of biscuit packets. Likewise, I have taken the example. Now, for that I have to count the object what is available. The trolley is already programmed to move by the time of 20 seconds it may be. Or otherwise I have switched on, the trolleys keep on moving. I am not depend upon the trolley timers, but I am depend upon the object counts. We will do now. You see, input 1 and 2. Items have to be counted. Items have to be counted as they pass along the conveyor belt. So it's the same example. Conveyor belt, the number of revolutions of a shaft, how many times it is rotating one shaft, maybe how many maybe traveling or rotating, what are some counts. Totally one revolution count is a count. 2 revolutions a count. 1000 RPM, 1000 revolutions is a count. So in the number of people is passing through, or the traffic number of people are passing through the door. So such are counts. In the supermarkets, only 100 are permitted per day or per hour as a crowded zone. So if more than that are there for 15 minutes in a crowd, it is not permitted. The halls, marriage halls can be occupied by only 100 chairs. So we can able to permit only 100 counts of heads, 100 counts of peoples. In such a way we can able to use this counter there, and it counts. If 100 is there, door will not open, and it will be 100 chairs are there. So we can able to restrict the remaining persons of which can be in the digital display. We can see 100 counts. Therefore, remaining the securities can able to stop them until their persons who are inside when they are coming out. So such cases we can able to do. So for example, a counter is set on some preset number of values. This counter has been set at counter I am setting up for 20. So I am setting the counter as 20 here, 20 counts to be done. And then this counters will have here, it is passing through. So this is maybe a counter 1, input has been given and it is counted. Keep on, the counter is coming 1, input 2. Input 1, input 2, input 3, input 4, input 5, input 6, 7, it will keep on counting. And then this keep on, output should come to reset. So when this 20 is reached, the counter is reaching the 20. And now the output is activated to restart again the starting position. And I want to fill the pockets, number of objects in the pocket. So 20 is filled. I have to restart and count from the number 1. In such a way, I will remove the box, fill the box, and I can able to keep the next box to fill again. So I want to reset the program and again started to count from 1 to 20 again. So what I am doing, this output I am connecting here as a, this output I am connecting here, this output I am connecting here as the out 1. So this output 1 has been taken as a contact here. When this after 20 counts, this output is activated. This output, when this output is activated, this output is taken as an input to reset. What happens then if we reset? This become, again it is 0. And now, here the next object comes as an input, but I am counting this as a 1. Next object comes inside, I am counting as a 2. And it keeps on going up to 20. So again, likewise, we can able to do the counting operations. It may be up counter or down counter. How it is? For it is while it is moving up, when it is started to move, we are counting. It means that the on condition I am considering as a up counter. The off condition and terminating condition I am considering as a off counter. The count from 0 to the present preset value I am counting in such a way. You see, I want to count up to 20, and now the object is 0th object going. This is 1 count, up count, 2nd, 3rd, 4th. It is started from 0 to 20. It is filling method I am considering as a up counter. Unfilling method, when it is taken out from the filled box and we are taking out to the stores, I am counting this as down counters. You know, when we have filled objects of the various filled box, and there is a census, when the box we have filled the van with the 100 packets of box which contains the object any biscuits packets, like which we can consider. Now from the van I am taking 2 bundles and delivering to the stocks, delivering to the stores. This 2 has been I have in the van I have a 25 box or otherwise a 100 box. I am taking out a 2 box and delivering in one store, and going to the next store, and again I am delivering the another 2 box. So from 100 it keep on decreasing, 2 minus 2 minus 2, likewise it keep on decreasing. The van will be empty when the count is going to 0. At the time I am going to stop. At the time I am going to stop, the van is going to empty. So such cases I can able to do in those programs. So activated when 0 reaches after the counting down the set value. It is called as down timer. From the 100 to 0, it is counted. Reverse counting, I am coming as a down counter. And then again it is restarted. But here it is an up counter. What I am doing? From 0 to the set value. Set value may be of 10, 20, whatever it is. And then it is going to disconnect. Again we have to, 20 is maximum is filled on the van. And then we can able to remove the various considerations. So likewise we can able to plan our things. You see? So here the reset button has been given, and the counter and the similar counter, and it counts. After the counter is started, 1, 2, 3, up to 20, this counter will activate. Whether it may be up counter, whether it may be a down counter, whatever it is, the connection is same. This, what I am doing, this counter I am connecting to the reset. So this reset is button is here, this reset 1. So this reset is going to disconnect, this reset is going to disconnect here, and then again reset will happen. The reset button will be pressed here, and again the counter going to start again. Such a way we can able to plan maybe for up counter or maybe for the down counter instructions. We have seen timer counters, logics, how to select in the single PLC. We in the laboratories normally for the normal functions for maintenance of home appliances, So we can able to have minimum number of ports. Based upon the output, number of outputs, we can select the PLC. It means the number of input and output required, number of input and output required for this. So such cases, I want to operate a lift, I want to operate a traffic jam signal. So there are many inputs are there. So multiple inputs are needed. I want to operate single water level management on the tank at home. So it should on, it should off. High level, low level. So it is to be sensitive. So we can able to take a low level at one sensor, high level at one sensor. Two inputs are there. And output motor should on off. So such cases depend upon the inputs and outputs, what the execution is there. Depend upon that, I am selecting a number of inputs and outputs. How to select the PLC? So there is a number of type of input and output, maybe a analog input or digital inputs, sensors we are using, what it is. So depend upon the input and output. Memory sizes required. So large program, we need more memories. So simpler program, we need less memories. So speed and the power of the processors. So those things are not depend upon selection of PLC. At home appliances, normal CPU, tasks like our home laptops, we are using some minimum requirement of the processors. But in the heavy industries, they are using a high-end systems. So likewise, you should select. So features and advantages of the PLC. It is able to programmable. Yes. Real-time operations. The PLC is always the PLC. What input we are giving, what output we are taking, it depends upon that. Maybe we are using for the experimental laboratory instruments, or otherwise we are using for the industrial to move the trolley. So those things can be programmed. So it's all real-time operations we are doing. So based upon that PLC, the real-time applications can do. The laboratory experiments can do. The same PLC. Therefore, the feature it is a real-time applications only. Uses easy ladder logic programs. Yes, simple. These are the ladder programs what we have seen. It is not a C program. It is not a Java program. It is simple ladders. Inbuilt testing of easy troubleshootings. Compact and economical. So it is a compact, small, and economical also based upon the setups. Fast responses. And easy to expand input and output ports. So I am able to expand input and output ports with respect to single PLC kit. PLC kit contains the processor, and those inputs and outputs points we can able to incorporate later according to the requirement. Able to expand. So input I am expanding, output also I can able to expand. Less cost and easy to repair are some of the features and advantages of the PLC. So the summary. In the PLC, we have talked about these types of ladder diagrams, ladder programs. On that we have seen about logic gates, off, and or and not functions we have seen. Accordingly, some this N and N OR gates also we have done. And after that, in the out of logic gates, we have seen the latching. And after the latching, we have seen the timers and also the counters also. The remaining part we have to continue some programs, otherwise the remaining part we have to see. The remaining part of the subject, we'll see you in the next session. Thank you.